Geology is the fascinating study of our planet, Earth. It delves into the Earth's composition, structure, and the forces that have shaped it. Geologists explore rocks, minerals, and fossils. These treasures hold clues to Earth's dynamic history. They tell stories of ancient climates and volcanic eruptions. Imagine holding a rock in your hand. To a geologist, it's a time capsule. It might be a piece of igneous rock from a volcano or a sedimentary rock formed over millennia. Metamorphic rocks are transformed by heat and pressure. Geology is about the past, present, and future. Understanding Earth's changes helps manage resources sustainably. Geologists help prepare for natural hazards. Geology is vast and rewarding. It reveals the power and beauty of the natural world. Rocks are the fundamental building blocks of our planet. They are made up of minerals, which are naturally occurring, inorganic solids with a definite chemical composition and crystal structure. There are thousands of different minerals, each with its own unique properties. Some minerals, like quartz, are very hard and durable. Others, like talc, are soft and easily scratched. Rocks are classified into three main types: igneous, sedimentary, and metamorphic. Igneous rocks form when molten rock called magma cools and solidifies. Sedimentary rocks form from the accumulation of sediments such as sand, silt, and clay. Metamorphic rocks are formed when existing rocks are changed by heat, pressure, or chemical reactions. The study of rocks is called petrology. Petrologists use a variety of techniques to study rocks, including field observations, microscopic analysis, and chemical analysis. By studying rocks, petrologists can learn about the history of the Earth, the processes that have shaped our planet, and the resources that are available to us. The rock cycle is a fundamental concept in geology that describes the continuous transformation of rocks from one type to another. This cycle is driven by the Earth's internal heat, which causes the mantle to convect, and external processes such as weathering, erosion, and deposition. The rock cycle begins with the formation of igneous rocks from magma. When magma cools and solidifies, it forms igneous rocks. These rocks can be exposed at the Earth's surface through volcanic eruptions or uplift. Once exposed, igneous rocks are subjected to weathering and erosion, which break them down into smaller particles called sediments. These sediments are then transported by wind, water, or ice and deposited in layers. Over time, these layers of sediment are buried and compacted, forming sedimentary rocks. If sedimentary rocks are buried deep enough, they can be subjected to intense heat and pressure, which transforms them into metamorphic rocks. Metamorphic rocks can also be formed from igneous rocks that are subjected to heat and pressure. The rock cycle is a continuous process, with rocks constantly being transformed from one type to another. It is a testament to the dynamic nature of our planet and the powerful forces that shape it. Plate tectonics explains the movement of the Earth's lithosphere, the rigid outermost shell of our planet. The lithosphere is broken into large plates that move over the semi-molten asthenosphere. These plates interact at their boundaries, creating geological features. There are three main types of plate boundaries: divergent, convergent, and transform. At divergent boundaries, plates move apart, creating new crust. The Mid-Atlantic Ridge is an example. At convergent boundaries, plates collide, forming mountains. The Himalayas formed this way. At transform boundaries, plates slide past each other, causing earthquakes. The San Andreas Fault is an example. Plate tectonics explains the distribution of continents, oceans, and geological features. It shows the dynamic nature of our planet and the forces shaping it.